Part 2, Chapter 12 of A Popular History of Astronomy During the 19th Century. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Shasta, Oakland, California. A Popular History of Astronomy During the 19th Century by Agnes Mary Clerke, Part 2, Chapter 12. Through Dr. Gould's unceasing labors during his 15 years' residence at Cordoba, a detailed acquaintance with southern stars was brought about. His Uranometria Argentina, 1879, enumerates the magnitudes of 8,198 out of 10,649 stars visible to the naked eye under those transparent skies. 33,160 down to 9 1/2 magnitude are embraced in his zones. The Argentine General Catalogue of 32,468 southern stars was published in 1886. Valuable work of the same kind has been done at the Leander McCormick Observatory, Virginia, by Professor O. Stone, while the late Redcliffe Observer's Cape Catalogue for 1880 affords inestimable aid to the practical astronomer south of the line, which has been reinforced with several publications issued by the present Astronomer Royal at the Cape. Moreover, the gigantic task entered upon in 1860 by Dr. C. H. F. Peters, director of the Litchfield Observatory, Clinton, New York, and of which a large installment was finished in 1882, deserves honorable mention. It was nothing less than to map all stars down to and even below the 14th magnitude, situated within 30 degrees on either side of the ecliptic, and so to afford a sure basis for drawing conclusions with respect to the changes going on in the starry heavens. It is tolerably safe to predict that no work of its kind and for its purpose will ever again be undertaken. In a small part of one night, stars can now be got to register themselves more numerously and more accurately than by the eye and hand of the most skilled observer in the course of a year. Fundamental catalogues constructed by the old time-honored method will continue to furnish indispensable starting points for measurement, and one of especial excellence was published by Professor Newcomb in 1899, but the relative places of the small crowded stars, the sidereal of hoi polloi, will henceforth be derived from their autographic statements on the sensitive plate. Even the secondary purpose, that of asteroidal discovery, served by detailed stellar enumeration, is more surely attained by photography than by laborious visual comparison. For planetary movement betrays itself in a comparatively short time by turning the imprinted image of the object affected by it from a dot into a trail. In the arduous matter of determining star distances, progress has been steady, and bids fair to become rapidly accelerated. Together, yet independently, Gill and Elkin carried out at the Cape Observatory in 1882-83 an investigation of remarkable accuracy into the parallaxes of 9 southern stars, One of these was the famous Alpha Centauri, the distance of which from Earth was ascertained to be just 1/3 greater than Henderson had made it. The parallax of Sirius, on the other hand, was doubled, or its distance halved, while Canopus proved to be quite immeasurably remote, a circumstance which, considering that among all the stellar magnitude it is outshone only by the radiant Dog star, gives a stupendous idea of its real splendor and dimensions. Inquiries of this kind were for some years successfully pursued at the observatory of Dunsink, near Dublin. Annual perspective displacements were, by Dr. Brunau, detected in several stars, and in others remeasured with a care which inspired just confidence. His parallax for Alpha Lyrae, 0.13", was authentic, though slightly too large. Elkin's final results gave pi equal 0.082", and the received value for the parallax of the swiftly traveling star Groombridge, 1830, scarcely differs from that arrived at by him in 1871, pi equals 0.09". His successor as Astronomer Royal for Ireland, Sir Robert Stawell Ball, now Laudian Professor of Astronomy in the University of Cambridge, has done good service in the same department. For besides verifying approximately Struve's parallax of half a second of arc for 61 Cygni, he refuted in 1811, by a sweeping search for so-called large parallaxes, certain baseless conjectures of comparative nearness to the Earth in the case of red and temporary stars. Of 450 objects thus cursorily examined, only one star of the 7th magnitude, numbered 1618 in Groombridge's circumpolar catalogue, gave signs of measurable vicinity. Similarly, a reconnaissance among rapidly moving stars lately made by Dr. Chase with the Yale heliometer yielded no really large and only 8 appreciably parallaxes among the 92 subjects of his experiments. A second campaign in stellar parallax was undertaken by Gill and Elkin in 1887, but this time the two observers were in opposite hemispheres. Both used heliometers. Dr. Elkin had charge of the fine instrument then recently erected in Yale College Observatory. Sir David Gill employed one of 7 inches, just constructed under his directions in first-rate style by the Repsolds of Hamburg. Dr. Elkin completed in 1888 his share of the more immediate joint program, which consisted in the determination by direct measurement of the average parallax of stars of the first magnitude. It came out for the 10 northern luminaries, after several revisions, 0.09", equivalent to a light journey of 33 years. The deviations from this average were indeed exceedingly wide. 2 of the stars, Betelgeuse and Cygni, gave no certain sign of any perspective shifting. Of the rest, Procyon, with a parallax of 0.334", proved nearest to our system. At the mean distance concluded for these 10 brilliant stars, the Sun would show as of only 5th magnitude, hence it claims a very subordinate rank among the suns of space. Sir David Gill's definitive results were published in 1900. As the average parallax of the 11 brightest stars in the southern hemisphere, they gave 0.13 minutes, a value enhanced by the exceptional proximity of Alpha Centauri. Yet 4 of these conspicuous objects, Canopus, Rigel, Spica, and Beta Crucis, gave no sign of perspective response to the annual change in our point of view. The list included 11 fainter stars with notable proper motions, and most of these proved to have fairly large parallaxes. Among other valuable contributions to this difficult branch may be instanced Bruno Peters' measurement of 11 stars with the Leipzig heliometer, 1887 to 1892. Kapteyn's application of the method by differences in right ascension to 15 stars observed on the meridian 1885 to 1889, and Flint's more recent similar determinations at Madison, Wisconsin. The great merit of having rendered photography available for the sounding of the celestial depths belongs to Professor Pritchard. The subject of his initial experiment was 61 Cygni. From measurements of 200 negatives taken in 1886, he derived for that classic star a parallax of 0.438 minutes, a satisfactory agreement with Ball's of 0.468 minutes. A detailed examination convinced the Astronomer Royal of its superior accuracy to Bessel's result with the heliometer. The Sevillian professor carried out his project of determining all second magnitude stars to the number of about 30, conveniently observable at Oxford, obtaining as the general outcome of the research an average parallax of 0.056 minutes for the objects of that rank. But this value, though in itself probable, cannot be accepted as authoritative in view of certain inaccuracies in the work adverted to by Jacobi, Herman Davis, and Gill. The method has nevertheless very large capabilities. Professor Kapteyn showed in 1889 practicability of deriving parallaxes wholesale from plates exposed at due intervals, and applied his system in 1900 with encouraging success to a group of 248 stars. The apparent absence of spurious shiftings justified the proposal to follow up the completion of the astrographic chart with the initiation of a photographic parallax Durchmusterung. Observers of double stars are among the most meritorious, and need to be among the most patient and painstaking workers in sidereal astronomy. They are scarcely as numerous as could be wished. Dr. Dobberk, distinguished as a computer of stellar orbits, complained in 1882 that data sufficient for the purpose had not been collected for above 30 or 40 binaries out of between 500 and 600, certainly or probably within reach. The progress since made is illustrated by Mr. Gore's useful catalogue of computed binaries, including 59 entries presented to the Royal Irish Academy, June 9, 1890. Few have done more towards supplying the deficiency of materials than the late Baron Ercole Dembowski of Milan. He devoted the last 30 years of his life which came to an end on January 19th, 1881, to the revision of the Dorpat catalogue, and left behind him a store of micrometrical measures as numerous as they are precise. Of living observatories in this branch, Mr. S. W. Burnham is beyond question the foremost. While pursuing legal avocations at Chicago, he diverted his scanty leisure by exploring the skies with a 6-inch telescope mounted in his backyard, and had discovered in May 1882 1,000 close and mostly very difficult double stars. Summoned as chief assistant to the new Lick Observatory in 1888, he resumed the work of his predilection with the 36-inch and 12-inch refractors of that establishment. But although devoting most of his attention to much-needed remeasurements of known pairs, he incidentally divided no less than 274 stars, the majority of which lay beyond the resolving power of less keen and effectually aided eyesight. One of his many interesting discoveries was that of a minute companion to Alpha Ursae Majoris, the first pointer, which already gives unmistakable signs of orbital movement round the shining orb it is attached to. Another pair, Kappa Pegasi, detected in 1880, was found in 1892 to have more than completed a circuit in the interim. Its period of a little over 11 years is the shortest attributable to a visible binary system, except that of Delta Equulae, provisionally determined by Professor Hussey in 1900 at 5.7 years, and indicated by spectroscopic evidence to be of uncommon brevity. Burnham's catalogue of 1,290 double stars discovered by him from 1871 to 1899 is a record of unprecedented interest. Nearly all the 690 pairs included in it 2 minutes or less than 2 minutes apart must be physically connected, and they offer a practically unlimited field for investigation, while the notes, diagrams, and orbits appended profusely to the various entries are eminently helpful to students and computers. The author is continuing his researches at the Yerkes Observatory, having quitted the Lick establishment in 1892. The first complete enrollment of southern double stars was made by Mr. R.T.A. Innes in 1899. The couples enumerated 21%, of which are separated by less than 1 second of arc, are 2,140 in number. They include 305 discovered by himself. Dr. C. gathered a rich harvest of nearly 500 new southern pairs with the Lowell 24-inch refractor in 1897. Professor Hoff's discoveries in more northerly zones amounted to 623, Hussey's at Lick to 350, and Aitken's already to over 300. There is as yet no certainty that the stars of 61 Cygni form a true binary combination. Mr. Burnham, indeed, holds them to be in course of definitive separation, and Professor Hall's observations at Washington 1879 to 1891, although favoring their physical connection, are far from decisive on the point. Dr. Wilsing, from certain anomalous displacements of their photographed images, concluded in 1893 the presence of an invisible third member of the system, revolving in a period of 22 months, but the effects noticed by him were probably illusory. Important series of double star observations were made by Perrotin at Nice in 1883 to 1884, by Hall, with the 26-inch Washington equatorial, 1874 to 1891, by Schiaparelli from 1875 onward, by Glassnapp, O. Stone, Leavenworth, Seabrook, and many besides. Finally, Professor Hussey's revision of the Pulkowa catalogue is a work of teres atque rotundus kind, which leaves little or nothing to be desired. The methods employed in double star determinations remain, at the beginning of the 20th century, essentially unchanged. The camera has scarcely encroached upon this part of the micrometer's domain. A research of striking merit into the origin of binary stars was published in 1892 by Dr. T.J.J.C. in the form of an inaugural dissertation for his doctor's degree in the University of Berlin. The main result was to show the powerful effects of tidal friction in prescribing the course of their development from double nebulae revolving almost in contact to double suns far apart yet inseparable. The high eccentricities of their eventual orbits were shown to result necessarily from this mode of action, which must operate with enormous strength on closely conjoined, nearly equal masses, such as the rapidly revolving pairs disclosed by the spectroscope. That these are still in an early stage of their life history is probable in itself, and is reaffirmed by the exceedingly small density indicated for the eclipsing stars by the ratio of phase duration to period. Stellar photometry, initiated by the elder Herschel and provided with exact methods by his son at the Cape by Steinheil and Seidel at Munich, has of late years assumed the importance of a separate department of astronomical research. Two monumental works on the subject, compiled on opposite sides of the Atlantic, were thus appropriately coupled in the bestowal of the Royal Astronomical Society's Gold Medal in 1886. Harvard College Observatory led the way under the able direction of Professor E.C. Pickering. His photometric catalogue of 4,260 stars, constructed from nearly 95,000 observations of light intensity during the years 1879 to 82, constitutes a record of incalculable value for the detection and estimation of stellar variability. It was succeeded in 1885 by Professor Pritchard's Uranometria Nova Oxoniensis, including photometric determinations of the magnitude of all naked eye stars, from the pole to 10 degrees south of the equator to the number of 2,784. The instrument employed was the wedge photometer, which measures brightness by resistance to extinction. A wedge of neutral tint glass, accurately divided to scale, is placed in the path of the stellar rays. When the thickness of it they have power to traverse furnishes a criterion of their intensity. Professor Pickering's meridian photometer, on the other hand, is based upon Zollner's principle of equalization effected by a polarizing apparatus. After all, however, as Professor Pritchard observed, the eye is the real photometer, and its judgment can only be valid over a limited range. Absolute uniformity, then, in estimates made by various means under varying conditions and by different observers, is not to be looked for, and it is satisfactory to find substantial agreement attainable and attained. Only in an insignificant fraction of the stars common to the Harvard and Oxford catalogues discordances are found exceeding 1/3 of a magnitude. A large proportion, 71%, agree within 1/4, a considerable minority, 31%, within 1/10 of a magnitude. The Harvard photometry was extended on the same scale to the opposite pole in a catalogue of the magnitudes of 7,922 southern stars, founded on Professor Bailey's observation in Peru, 1889 to 1891. Measurements still more comprehensive were subsequently executed at the primary establishment. With a meridian photometer of augmented power, the surprising number of 473,216 settings were made during the years 1891 to 98, nearly all by the indefatigable director himself, and they afforded materials for a photometric Durchmusterung, published in 1901, including all stars of 7.5 magnitude north of declaration -40 degrees. A photometric zone 20 degrees wide has for some time been in course of observation at Potsdam by M.M. Müller and Kempf. The instrument employed by them is constructed on a polarizing principle as adapted by Zollner. Photographic photometry has meanwhile risen to an importance, if anything, exceeding that of visual photometry. For the usefulness of the great international star chart now being prepared would be gravely compromised by systematic mistakes regarding the magnitude of the stars registered upon it. No entirely trustworthy means of determining them have, however, yet been found. There is no certainty as to the relative times of exposure needed to get images of stars representative of successive photometric ranks. All that can be done is to measure the proportionate diameters of such images, and to infer, by the application of a law learned from experience, the varied intensities of light to which they correspond. The law is, indeed, neither simple nor constant. Different investigators have arrived at different formulae, which, being purely empirical, vary their nature with the conditions of the experiment. Probably the best expedient for overcoming the difficulty is that devised by Pickering, of simultaneously photographing a star and its secondary image reduced in brightness by a known amount. The results of its use will be exhibited in a catalogue of 40,000 stars to the 10th magnitude, one for each square degree of the heavens. A photographic photometry of all the lucid stars, modeled on the visual photometry of 1884, is promised from the same copious source of novelties. The magnitudes of the stars in the Draper catalogue were determined, so to speak, spectrographically. The quantity measured in all cases was the intensity of the hydrogen line near G. By the employment of this definite and uniform test, results were obtained of special value indeed, but in strong disaccord with those given by less exclusive determinations. Thought, meanwhile, cannot be held aloof from the great subject upon the future illustration of which so much patient industry is being expended. Nor are partial glimpses denied to us of relations fully discoverable, perhaps, only through centuries of toil. Some important points in cosmical economy have, indeed, become quite clear within the last 50 years, and scarcely any longer admit of a difference of opinion. One of these is that of the true status of nebulae. This was virtually settled by Sir J. Herschel's description in 1847 of the structure of the Magellanic Clouds, but it was not until Whewell in 1853 and Herbert Spencer in 1858 enforced the conclusions necessarily to be derived therefrom, that the conception of the nebulae as remote galaxies, which Lord Rosse's resolution of many interstellar points had appeared to support, began to withdraw into the region of discarded and half-forgotten speculations. In the nebulae, as Whewell insisted, there coexist in a limited compass and in indiscriminate position stars, clusters of stars, nebulae, regular and irregular, and nebulous streaks and patches. These, then, are different kinds of things in themselves, not merely different to us. There are such things as nebulae side by side with stars, and with clusters of stars. Nebulous matter resolvable occurs close to nebulous matter irresolvable. This argument from coexistence in nearly the same region of space, reiterated and reinforced with others by Mr. Spencer, was urged with his accustomed force and freshness by Mr. Proctor. It is unanswerable. There is no maintaining nebulae to be simply remote worlds of stars in the face of an agglomeration like the Nebula Major, containing in its certainly capacious bosom both stars and nebula. Add the facts that a considerable proportion of these perplexing objects are gaseous, and that an intimate relation obviously subsists between the mode of their scattering and the lie of the Milky Way, and it becomes impossible to resist the conclusion that both nebular and stellar systems are parts of a single scheme. As to the stars themselves, the presumption of their approximate uniformity in size and brightness has been effectually dissipated. Differences of distance can no longer be invoked to account for dissimilarity in luster. Minute orbs, altogether invisible without optical aid, are found to be indefinitely nearer to us than such radiant objects as Canopus, Betelgeuse, or Rigel. Moreover, intensity of light is perceived to be a very imperfect index to real magnitude. Brilliant suns are swayed from their course by the attractive power of massive yet faintly luminous companions, and suffer eclipse from obscure interpositions. Besides, effective lustre is now known to depend no less upon the qualities of the investing atmosphere than upon the extent and radiative power of the stellar surface. Red stars must be far larger in proportion to the light diffused by them than white or yellow stars. There can be no doubt that our sun would be at least double its brightness were the absorption suffered by its rays to be reduced to the Sirian standard, and, on the other hand, that it would lose half its present efficiency as a light source if the atmosphere partially veiling its splendors were rendered as dense as that of Aldebaran. Thus, variety of all kinds is seen to abound in the heavens, and it must be admitted that the consequent insecurity of all hypotheses as to the relative distances of individual stars singularly complicates the question of their allocation in space. Nevertheless, something has been learnt even on that point, and the tendency of modern research is, on the whole, strongly confirmatory of the views expressed by Herschel in 1802. He then no longer regarded the Milky Way as the mere visual effect of an enormously extended stratum of stars, but as an actual aggregation, highly irregular in structure, made up of stellar clouds and groups and nodosities. All the facts since ascertained fit in with this conception, to which Proctor added arguments favoring the view since adopted by Barnard and Easton, that the stars forming the galactic stream are not only situated more closely together, but are also really, as well as apparently, of smaller dimensions than the lucid orbs studding our skies. By the laborious process of isographically charting the whole of Argelander's 324,000 stars, he brought out in 1871 signs of relationship between the distribution of the brighter stars and the complex branchings of the Milky Way, which has been stamped as authentic by Newcomb's recent statistical inquiries. There is, besides, a marked condensation of stars, especially in the southern hemisphere, toward a great circle inclined some 20 degrees to the galactic plane, and these were supposed by Gould to form with the sun a subordinate cluster, of which the components are seen projected upon the sky as a zone of stellar brilliance. The zone has, however, galactic rather than solar affinities, and represents, perhaps, not a group, but a stream. The idea is gaining ground that the Milky Way is designed, in its main outlines, on a spiral pattern, and that its various branches and sections are consequently situated at very different distances from ourselves. Proctor gave a preliminary interpretation of their complexities on this principle, and Easton of Rotterdam has renewed the attempt with better success. A most suggestive delineation of the Milky Way, completed in 1889 after 5 years of labor by Dr. Otto Boedicker, Lord Rosse's astronomer at Parsonstown, was published by lithography in 1892. It showed a curiously intricate structure, composed of dimly luminous streams and shreds and patches, intermixed with dark gaps and channels. Ramifications from the main trunk ran out toward the Andromeda Nebula, and the Beehive cluster in Cancer involved the Pleiades and Hyades, and winding round the constellation of Orion, just attained the sword-handle nebula. The last delicate touches had scarcely been put to the picture when the laborious eye and hand method was, in this quarter, as already in so many others, superseded by a more expeditious process. Professor Barnard took the first photographs ever secured of the true Milky Way, July 28, August 1st and 2nd, 1889, at the Lick Observatory. Special conditions were required for success. Above all, a wide field and a strong light grasp, both complied with through the use of a 6-inch portrait lens. Even thus, the sensitive plate needed some hours to pick out the exceedingly faint stars collected in the galactic clouds. These cannot be photographed under the nebulous aspect they wear to the eye. The camera takes note of their real nature, and registers their constituent stars rank by rank. Hence the difficulty of disclosing them. In the photographs made with the 6-inch portrait lens, Professor Barnard wrote, besides myriads of stars, there are shown for the first time the vast and wonderful cloud forms, with all their remarkable structure of lanes, holes, and black gaps, and sprays of stars. They present to us these forms in all their delicacy and beauty, as no eye or telescope can ever hope to see them. In Plate 6, one of these strange galactic landscapes is reproduced. It occurs in the bow of Sagittarius, not far from the Trifid Nebula, where the aggregations of the Milky Way are more than usually varied and characteristic. One of their distinct features comes out with particular prominence. It will be noticed that the bright mass near the center of the plate is tunneled with dark holes and furrowed by dusty lanes. Such interruptions recur perpetually in the Milky Way. They are exemplified on the largest scale in the great rift dividing it into two branches, all the way from Cygnus to Crux, and they are reproduced in miniature in many clusters. Mr. H. C. Russell, at Sydney in 1890, successfully imitated Professor Barnard's example. His photographs of the southern Milky Way have many points of interest. They show the great rift, black to the eye, yet densely star-strewn to the perception of the chemical retina, while the coal sack appears absolutely dark only in its northern portion. His most remarkable discovery, however, was that of the spiral character of the two nebecula. With an effective exposure of 4½ hours, the greater cloud came out as a complex spiral with two centers, while the similar conformation of its minor companion developed only after 8 hours of persistent actinic action. The revelation is full of significance. Scarcely less so, although after a different fashion, is the disclosure on plates exposed by Dr. Max Wolf with a 5-inch lens in June 1891 of a vastly extended nebula, bringing some of the leading stars in Cygnus into apparently organic connection with the piles of galactic stardust likewise involved by it. Barnard has similarly found great tracts of the Milky Way to be photographically nebulous, and the conclusion seems inevitable that we see in it a prodigious mixed system, resembling that of the Pleiades in point of composition, though differing widely from it in plan of structure. Of corroborative testimony, moreover, is the discovery independently resulting from Gill's and Pickering's photographic reviews that stars of the first type of spectrum largely prevail in the galactic zone of the heavens. With approach to that zone, Kapteyn noticed a steady growth of actinic intensity relative to visual brightness in the stars depicted on the Cape Durchmusterung plates. In other words, stellar light is, in the Milky Way, bluer than elsewhere, and the reality of the primitive character hence to be inferred for the entire structure was, in a manner, certified by Mr. Maclane's observation that helium stars, the supposed immediate products of nebulous matter, crowd towards its medial plane. The first step toward the unravelment of the tangled web of stellar movements was taken when Herschel established the reality and indicated the direction of the sun's journey. But the gradual shifting backward of the whole of the celestial scenery amid which we advance accounts for only a part of the observed displacements. The stars have motions of their own besides those reflected upon them from ours. All attempts, however, to grasp the general scheme of these motions have hitherto failed. Yet they have not remained wholly fruitless. The community of slow movements in Taurus, upon which Mädler based his famous theory, has proved to be a fact, and one of very extended significance. In 1870, Mr. Proctor undertook to chart down the directions and proportionate amounts of about 1,600 proper motions, as determined by Messrs. Stone and Main, with the result of bringing to light the remarkable phenomenon termed by him star drift. Quite unmistakably, large groups of stars, otherwise apparently disconnected, were seen to be in progress together, in the same direction and at the same rate across the sky. An example of this kind of unanimity was alleged by him in the 5 intermediate stars of the Plough, and that the agreement in thwartwise motion is no casual one is practically demonstrated by the concordant radial velocities determined at Potsdam for 4 out of the 5 objects in question. All of these approach the earth at the rate of about 18 miles a second, and the 5th and faintest, delta Ursae, though not yet measured, may be held to share their advance. One of them, moreover, Zeta Ursae, alias Mizar, carries with it 3 other stars. Alcor, the Arab rider of the horse, visible to the naked eye, besides a telescopic and a spectroscopic attendant, so that the group may be regarded as octuple. It is of vast compass. Dr. Herfler assigned to it in 1897, although on grounds more or less hypothetical, a mean parallax corresponding to a light journey of 192 years, which would give to the marching squadron a total extent of at least 14 times the distance from the Sun to Alpha Centauri, while implying for its brightest member, Epsilon Ursae Majoris, the luster of 600 suns. The organizing principle of this grand scheme must long remain mysterious. It is no solitary example. Particular association, indeed, as was summarized by Mitchell far back in the 18th century, appears to be the rule rather than an exception in the sidereal system. Stars are bound together by twos, by threes, by dozens, by hundreds. Our own sun is, perhaps, not exempt from this gregarious tendency. Yet the search for its companions has, up to the present, been unavailing. Gould's cluster seems remote and intangible. Kapteyn's collection of solar stars proved to have been a creation of erroneous data, and was abolished by his unrelenting industry. Rather, we appear to have secured a compartment to ourselves for our long journey through space. A practical certainty has, at any rate, been gained that whatever aggregation holds the Sun as a constituent is of a far looser build than the Pleiades or Praesepe. Of all such majestic communities, the laws and revolutions remain, as yet, inaccessible to inquiry. Centuries may elapse before even a rudimentary acquaintance with them begins to develop, while the economy of the higher order of association, which we must reasonably believe that they unite to compose, will possibly continue to stimulate and baffle human curiosity to the end of time. End of chapter 12.